Bismillah ar-Rahman ar-Rahim. So far, we have been discussing the kinematics. Kinematics is the description of how things work, how things move. So we discussed the displacement, we discussed distance, velocity, speed, acceleration, motion in one dimension, free fall, motion in two dimensions, projectile motion, and so on. Circular motion, for example. This was the field of kinematics. Now we'll start another type of discussion, which is called the dynamics. Okay? What do we mean by dynamics? Dynamics is answering the question why things work, why things move like this, why the acceleration of the object is like this, or increasing, decreasing, why is it constant? Okay? The answer for this, why things move or why things accelerate, because of the force. Okay? Now we'll start discussing the force. You will find in different references different definitions for the force, but the simplest definition is that the force is a pull or a push. Okay? And this pull or push can be by contact or it can be remotely. Let me give you an example of contact force. I can apply a force on this pin. Is this clear? So this is a pin. I cannot move it unless I touch it. Okay, so this is a push. When I touch it, there is a push. Similarly, this is a pull. So my force, which I can exert on object, will act by contact. Another force which can act remotely is the gravitational force. Earth is pulling on objects, not necessarily to be in touch. They might be remote objects, like this pen. If I leave it, Earth is pulling it downward, and this force, without touching the object, as you can see, the object falls down, and the Earth is pulling it remotely, without touching it. Okay? This force is a vector quantity. Okay, so the force, when we deal with it, keep in mind the laws of vectors. So if you want to add forces, don't add them with simple addition, but it should be the vector addition. As we learned before how to add vectors, okay, if you want to add forces, you have to keep in mind that they are vectors. Okay, if you want to subtract them or multiply them with constants, multiply other vector or cross product, dot product, don't forget to treat the forces as vectors. Okay, one of the scientists is Isaac Newton. He had very great contribution to this field of dynamics, and we will discuss his three laws of motion. The first law, so we have Newton's laws of motion. The first one of them is Newton's first law. Sometimes we call it the concept of inertia, or the law of inertia. It says simply, if there is no net force exerted on an object, no net force, there might be forces, but these forces add up, or the resultant of these forces is equal to 0. There is a pull from this side with, say, 5 Newton, and we have pull from the other side, okay, with the same magnitude but in the opposite direction. So the net force is equal to 0. If the net force on an object is equal to 0, this implies that its acceleration will be 0. It will not accelerate. What do we mean by the acceleration is equal to 0? We know that the acceleration is the rate of change of the velocity. If the acceleration is 0, this means that the rate of change of the velocity will be 0. What does it mean? It means the velocity will be constant. Okay? And the opposite is correct. Okay? We say that if the net force equal to 0, this means the acceleration is 0 and the velocity will be 0. If you notice an object moving with constant velocity, let me start from here. It moves with constant velocity. So it comes to your mind directly that the acceleration of this object is 0, and if the acceleration of this object is 0, this means the net force on it is equal to 0. In this case, we call that our object is in equilibrium. And this equilibrium might be a static equilibrium when the object is not moving, when the velocity is 0. Right now, I am not moving, so my velocity is 0, means that my acceleration is 0, and the net force on me is equal to 0. And I am said that I am in static equilibrium. Okay? Another type of equilibrium is the dynamic equilibrium. If the object is moving with constant velocity. Okay? If you see a car and the car is moving in a straight line, okay, with constant speed, let us say 120 km per hour in the same direction, there is no change in the direction, we say that that car is in dynamic equilibrium. Its acceleration is equal to 0, and the resultant force or the net force on my car is equal to 0. Okay, we are done with Newton's first law. Let us describe Newton's second law. Newton's second law says that the acceleration of an object is directly proportional to the net force or the resultant force on the object, and inversely proportional with its mass. Okay, so if the net force on my object is increased, the acceleration will increase. But if the mass of my object is increased while keeping the resultant force fixed, not changed, what will happen to my acceleration? Acceleration will decrease. There is inverse proportionality between the mass and the acceleration. This is very important relationship. And also we notice that the direction of my acceleration is a vector. The net force or the resultant force is a vector. The direction of the acceleration is the same as the direction of the resultant force or the net force. Why? Because m is a scalar quantity and it is always positive. Okay, so this is always positive and it is a scalar. So the direction of the acceleration is the same as the direction of the resultant force or the net force. Okay, so this equation is a vector equation. So we can write it in three components: x component of the acceleration, y component of the acceleration, and the z component of the acceleration. X component of the acceleration will be the net force along the x-axis divided by the mass. The y component of acceleration will be the net forces along the y-axis divided by the mass of the object. And the z component of the acceleration will be the net forces along the z-axis divided by the mass of the object. So A, the acceleration has units of meter per second square. The mass is a scalar quantity. It has units of kilogram. By the way, these are the SI units. There are other units as well, but we will use in this course only the SI units. So here we find that the unit of the force will be the unit of the acceleration multiplied by the unit of mass, and we will end up with unit of kilogram meter per second square as the unit for the force. But this is too long, so we'll be replacing it with capital N, stands for Newton. So what is the unit of the force? It is kilogram meter per second square, but we'll not use it. We'll replace it with Newton, after the scientist Isaac Newton, who contributed a lot to this field of dynamics. Now let us move to Newton's third law. Newton's third law, the statement of it: if you have two objects and they interact means touch each other or push on each other, the forces on the objects from each other are always equal in magnitude and opposite in direction. Here I have two objects, A and B. They are moving on this surface or sliding on the surface. So object A is pushing an object B with a force, we call it FBA. As a result, object B will push against object A with a force, we call it FAB. Okay, so this is the force. Let us give it the vector on top of it, the arrow. According to Newton's third law, it says that these two forces, due to the interaction between the two objects, they are equal in magnitude. So the magnitude of FAB, the force on A from B, equals the force on B from A. So they are equal in magnitude, but they are opposite in direction. So FAB equals minus FBA. So this is very important law, and no matter the objects, which one of them is large or which one of them is small, the interaction between them or the push of one object on the other will be equal in magnitude as the push of the other object on the first, but in the opposite direction. So if you hit your friend, okay, with a certain force, okay, so there is a force from your hand on your friend. As a result, your friend will act on your hand with an equal force, but in the opposite direction. Okay, so whatever you deliver, you will receive back. Okay, so be careful. If you hit something, you will receive the same from that thing, and you might hurt yourself, by the way. By this, we covered all Newton's laws, Newton's first law, and Newton's second law, Newton's third law. Thank you.